Well, hello everybody. Sorry I missed class today, or sorry that you missed class. Hey, here's the plans for the day. I need to cover with you in Chapter 2, Day 11. What this is over, it's what we call step functions. It'll be brand new to you. You have never, ever seen anything like this in your Algebra 1 days or your geometry days. Guys, what you're going to see today is you're going to see a graph that looks like steps. So you're going to see things that's going to look like this. It's a brand new lesson that I just invented this year. And then the way we decided to attack it is on real-world type of problems. I think you'll understand that the best. So you really won't need a calculator at all today, but if you do, you definitely won't need a graphing calculator. We used a graphing calculator the last couple of days. It won't be needed today. Your regular cheaper calculator would work. And like I said, brand new lesson for you. But the plans today, if I was there, I'd answer any questions on the homework. We will do a homework quiz today, graphing calculator, make sure you understand how to graph parabolas and the absolute value functions. And then we'll cover the step functions. So have your class notes in front of you, and then we'll go from here. One of my suggestions to you today, read carefully and really think about the problem. Think about how things are changing. So let's look at your number 1. It says a common piecewise linear function is a step function. The graph of a step function consists of little line segments. So think about this. To mail a first-class letter weighing 1 ounce or less costs 49 cents. So you take an envelope to the post office. If it's 1 ounce or less, all the way up to 1 ounce, it's only going to cost you 49 cents. The postage for the first-class letter jumps by 21 cents for each additional ounce. So what's that mean, guys, is if you bring in a letter that is anywhere from 1.1 ounces all the way up to 2 ounces, you're going to pay 49 cents, the initial amount, plus 21 more. Now, let's say that you bring in a letter and it weighs 3.3 ounces. You're going to pay that initial 49 cents. You're going to pay another 21 cents while it's in the 2 ounces. You're going to pay an additional 21 cents for the next ounce. So this would cover from 0 to 1, 1 to 2, 2 to 3, and then I got another 21 cents in there. So it jumps. So there's no in-between numbers. So think about this. The hardest thing on this, guys, is just trying to realize what's going on. So if your letter weighs less than an ounce, 1 ounce or less, you're going to pay 49 cents. Now look at how I wrote this here. See, this 0 is less than x, less than or equal to 1. Here's what that says. As long as the weight of your letter is more than 0 ounces, but less than or equal to 1 ounce, I'm going to charge you 49 cents to mail that letter. So in that first column there, guys, you're going to put a 49 cents. Now let's see what this next line says. It says 1 is less than x, which is less than or equal to 2. Here's what that says. If you bring in a letter and it weighs more than 1 ounce, all the way up to 2 ounces, so 1, 1.1, 1.2, 1.3, 1.44, 1.6, 7, 8, 9, all the way up to 2, I'm going to charge you 49 cents plus 21 more cents for a total of 70 cents. Kind of see how it's working so far? Now, let's say that it weighs a little bit more. The next line I got is 2 is less than x, which is less than or equal to 3. Here's what this says. If you bring me a letter weighing more than 2 ounces, but less than or equal to 3, I'm going to charge you an additional 21 cents. So I'm going to take that 70 cents from above, add 21 more cents to it, so it's going to cost you 91 cents. And on the next one, if it weighs between 3 to 4, I'm going to charge you another 21 cents. So I'm going to take that 91 plus 21 and get 112 cents, or $1.12. So guys, that's what the table looks like. Now just make sure you understand how to read it. The reason I included the right-hand side this time, because it says 1 ounce or less. If it weighs 1 ounce, I'm charging you this cheaper amount. Now, as a function, here's what it's going to look like. We're going to have a function that looks like this. Got some scribbles there I want to get rid of. So if you would, put a f of x and kind of write little. So draw that if you would. This is what we call a piecewise function, because it's going to have multiple equations in there, and it's not going to be continuous, meaning I can't draw the graph without picking up my pencil. So here's how it's going to look. I'm going to charge you 49 cents. When am I going to charge you 49 cents? If your letter weighs between 0 and 1 ounce. So 49 cents if your letter weighs between 0 and 1 ounce. I'm going to charge you 70 cents if your letter weighs between 1 ounce and up to 2. You get to keep it all the way up to 2, but as soon as you hit 2.01, I'm charging you more. I'm going to charge you 91 cents if your letter weighs more than 2 ounces, but less than or equal to 3. And my next one, I'm going to charge you 112 cents if your letter weighs more than 3, but less than 4. So that's what we got going on so far. That's what the function will look like. You tell people what it costs, and then the constraint. When does it cost that for you? And guys, if I get going too fast on the video, feel free to hit pause and write down what I have, or rewind a little bit and you can get it. Now, the graph's going to be a little bit different. The graph's going to be a little bit different. All of our graphs need 3 things. I need you to give me a title of the graph, and we'll write that up top. In this case, I decided to call it mail cost, postage cost, cost of mailing a letter. Okay, anything like that would work. That's going to be my title. Down here is going to be my x-axis. Guys, whenever we give you a chart, these are going to be your x's, these are going to be your y's. So my x's is going to be the weight. And then tell the world what the weight is in. In this case, I'm in ounces. So I put weight in ounces. Now, I jammed myself on room a little bit. So I'm going to erase this so I can write a little bit. So I'm going to get rid of these. Don't do that to your paper, of course. If you didn't have it all written down, rewind it just a little bit and write that down. Now, the y is going to be the cost. So I'm going to put, this is the cost, and right now we're in cents. Now, to graph this, here's what it looks like. Notice what your x's do. They go 0 to 1, 1 to 2, 2 to 3, 3 to 4. So on the weights, I'm going to go 0 to 1 to 2 to 3 to 4. Now this is really important. On your y values, you have to count by the same amount every time. So you're going to see this a lot. Notice that after 49 cents, I keep adding 21. So I'm going to do this. I'm going to put a squiggly line in there and 49. Guys, what that squiggly line means is there's some numbers less than 49. I'm just not using them. I'm starting at 49. Now, since I'm adding the same number every time, 21, that's what we're going to do. So this will be 70 cents. This line will represent 91 cents. This line will represent 112 cents. Now, here's what the graph is going to look like. If you don't come in, I'm charging you 0 because you didn't bring me anything. Now, I'm charging you 49 cents if your letter weighs anywhere from 0 to 1 ounce. So I'm going to have an open dot right there because I'm not charging you anything, and I'm going to have a closed dot right there because at 1 ounce I'm charging you 49 cents. But as soon as you go over 1 ounce, I'm charging you more, and I'm going to connect that. So guys, it made a line segment. Now, let's think what we're doing now. If your letter weighs 1 ounce to 2 ounces, I'm charging you 70 cents. So I'm going to have an open dot right there. Reason being, if your letter weighs 1 ounce, I'm charging you 49 cents, not 70. So that's why that's open. But at 2 ounces, I am charging you 70 cents. So I'm going to connect that. Now, as soon as you go over 2 ounces, I'm bumping the price up again. So I'm going to put an open dot there, a closed dot there, and I'm connecting. And then one more, as soon as you go over 3 ounces, at 3 ounces is an open dot because at 3 I'm charging you 91 cents. But at 4 I'm charging you right there. Now guys, notice what this looks like. It looks like a set of stairs. That's why we call this a stair-step function. Something I want to point out, notice that one side is open, the other side is closed. Depending on the problem, we have to decide which side is open and which side is closed. I knew this side was closed because I didn't charge you more until you broke 1 ounce. But as soon as you did that, I'm charging you more. So that's why it was an open dot. Now, come down, so look at all the pieces of the graph, guys, and hit pause if you need to. I've got a title. I've got a label for my x-axis. I've got a label for my y-axis. I've got a squiggly line because I jumped up to 49 cents, and then I just added 21 every time. Now look at your 1B. These are the easy parts. It says find f of 1.3. That is the price of an envelope that weighs 1.3 ounces. You come up into your function or your chart and see where 1.3 falls. Is it between 0 and 1? Is it between 1 and 2? Yes, it is. So boom. Right there means f of 1.3 is 70 cents. F of 2.9, go see where 2.9 falls. It falls between 2 and 3, so I'm charging you 91 cents. So guys, there's a lot there. There's a lot there. I need to pick the pace up, otherwise this will be an hour-long video. So come over to your number 2 if you would. Read the problem and see what happens. See if you can figure out where we're jumping. It says, Dave created an app that's a knockoff of Uber. If you use this app, he will come pick you up and give you a ride to whatever destination you desire. His app will charge you $2.50 for him to pick you up. Then for every whole mile you drive, you will be charged $1.25 per mile. Fill out the table, write the function, and make a step graph for the function. So be the problem for a second. You call Dave up. As soon as he gets there, you owe him $2.50. Now, what do you get for that $2.50? It says his app will pick you up. Then for every whole mile you drive, you'll be charged $1.25. So For $2.50, he will drive you anywhere from 0 to 1 mile. 0 to 1 mile. But what's he doing as soon as you get to 1 mile? As soon as you get to 1 mile, he's charging you $2.50. That's ugly to read, $2.50. He's charging you $2.50 and another $1.25. That's going to be good. Don't write that in the function space, though, by the way. That's going to be good for 1 to 2 miles. You can go all the way up to 2 before he charges you extra. So let's come over and look at the table real fast. See if I've got this right. If you want to ride 0 to 1 mile, he's going to charge you $2.50, and that's it. So, click, click, click. You can go 0.99 miles, and he's not charging you extra. But as soon as you get to 1, he's charging you the $2.50 plus another $1.25. So he's charging you $3.75. That's good until you get up to 2 miles. As soon as you get over 2 miles, I'm charging you another $1.25. So now he's charging you $5. As soon as you're over that, we're going to charge you another. So there's what it looks like so far. Now, your function's going to look like this. I'm going to have f of x equal. Now tell the world what's happening. I'm going to charge you $2.50 if your distance is more than 0 miles but less than 1. More than 0 miles but less than 1. But as soon as you hit 1, I'm charging you an extra $1.25. So you owe me $3.75 if you've hit a mile, but you're less than 2. I'm going to charge you $5 if you're more than 2 miles, but less than or equal to 3. And I'm going to charge you $6.25 if you hit 3 miles, but all the way up to 4. So there's what we got so far. So now, guys, now we're going to graph it. So some things that you need again. Give it some title. I called mine Dave's Taxi. You could call it Dave's Uber. You can call it whatever you want. Now, my x-axis happens to be dealing with miles. So I put miles down here. Now, what's your y values deal with? It deals with the fare, the cost. So what I'm going to do over here is I'm going to say the y-axis deals with the fare, and I'm going to go parenthesis a $sign. That's an ugly $sign, but that's a $sign. So there's my start. Now, your x's 0 to 1, 1 to 2, 2 to 3. So down here on the miles, let's go 0, 1, 2, 3, and 4. Let's look at what your fare did. I'm going to use a squiggly line, and I'm going to put $2.50. And it looks like I should have gave you a little bit more room. Now, I did that squiggly line because I jumped to $2.50, but now I'm only going to add a $1.25. So this line is going to represent $3.75. So once again, I'm going to get rid of this out of my way a little bit so I can write. So this will represent $3.75. This will represent $5. And this will represent 6 1/4. So here goes. If you don't call me, it's 0. So I'm going to put an open dot at 0, and I'm going to let you go all the way to 1. But I'm also going to put an open dot there, which looks weird. Open dot, but why did I do that? Because at a mile, once that odometer clicks a mile, bam, I'm charging you extra. I'm going to let you go distance until 2. Now notice the open dot, because what am I doing at 2? When that thing clicks from 1.99 to 2, I'm charging you extra. So close dot there, all the way to 3, boom. Once you've established your pattern, it's easy. Closed dots are going to be to the left, closed dot, open dot, boom. So there's what the graph looks like, guys. So key things again, give your graph a title, label your x-axis, label your y-axis. Remember earlier I had labeled this as fare in dollars. And then there's the stair-step graph. Let me do either number 3 or number 4 with you, and then I'll show you round up and round down functions. Okay. So let's look at number 3 now. It says, you want to bring cupcakes to school for your birthday. That's so nice of you. Each case comes with 12 cupcakes and costs $6.95. Create a function that models the cost of the cupcakes based on the number of students in your class. So I want to create a function here. Notice that my chart's blank this time, guys. Notice that I want it to have the cost and the number of students in your class. So think about this. If you buy one case, how many friends, including yourself, can you feed? Well, you can feed anywhere from none to 12. So over here in your chart, what I'm going to do is I'm going to put friends and cost. And I'll try to make friends look a little bit nicer. When I use this new software, it doesn't always work right. Now, think about this. We're going to start at 0. I'm going to have 0 is less than x, which is less than. Now, think about this. If you buy one case, you can feed up to 12 total. So 0 to 12. Now, notice this. I'm going to rewrite that too. Notice this. The 0 was not underlined, but this one is. Because as soon as you have 13 friends, what do you got to do? Somebody's got to do without, or you got to buy another case. So far we bought one case for $6.95. Now, as soon as we get to friend number 13, we're going to have to buy more. Now, one thing when you make your chart, we want this number to repeat. It'll help us on the x. So I'm going to do this now. 12 is less than x, which is less than or equal to 24. Now notice I did not include 12 because 12's included up here. So instead of putting 13, we want this number to be the same. That way when we count over here, it's going to help. Now notice, guys, once again, I did an underline with the 24 because I can now feed up to 24. If that means I have to buy two cases, $6.95 plus $6.95 is 1390. My next line, I want to use that 24 again, is less than x, which is less than or equal to 36. Because now I can feed up to 36. But what's that going to cost me? Another $6.95. So $13.90 plus $6.95 is $20.85. Now, think about this. That's probably enough, isn't it? If you got more than 36 in your class, man, something's wrong. So let's stop there. Now, I'm going to write my function below this time. So my function is going to look like this. F of x equal the big old brace. Now, let's just tell the world what's happening. It's going to cost me $6.95 if my x value is more than 0 but less than or equal to 12. So notice I included the 12. It's going to cost $13.90 if x is more than 12 but less than or equal to 24. And it's going to cost me $20.85 if I'm more than 24 but less than or equal to 36. So the hard part, guys, is deciding what to include. Do you include the number on the right or the left? Well, 12 was covered in the first case. 24 was covered in the second case. Now let's graph this. Give your graph a title again. This time I called mine cupcake cost. My x-axis was the cupcake number. I could have done that. I could have also called it friends. I could have called it classmates. Okay, so you got a lot of different options there. Now, my y-axis is going to be the cost. So I'm going to come over here and put cost. Maybe. And my cost is in dollars. Okay. Now, look at what we've been counting by. We went 0 and 12, 12 and 24, 24 and 36. Can you predict what I'm going to count by on the x-axis? 12s. So this is going to be 0 friends, 12 friends, 24 friends, 36 friends. Now, when I do my cost, I'm going to put $6.95 right there. I'm going to put $13.90 right there. And I'm going to put $20.85 right there. Now, notice I didn't do the little squiggle. The reason I didn't have to do that this time, guys, they were multiples of $6.95. So now, if you have 0 friends in a classmate, you're paying $0. So my closed dot would be right there. So now, how much are you spending if you have 0 friends? None. So I'm going to have an open dot right there. But all the way up to 12. So I'm going to put the closed dot on 12. The reason being, one case covers 12 people. So there's the first stair. From 12 to 24, I've got an open dot on 12 and a closed dot on 24. Because how many people will that second case cover? More than 12 but less than or equal to 24. And then my last one, open dot, close dot, boom. So guys, there's what we got so far. Now, I'm going to hope this is kind of enough to kind of get you rolling. We'll try to set this one up real fast just so you can see what the chart would look like. I won't spend time to do the graph since it's a video. It says renting jet skis in the Bahamas costs $40 an hour plus a $15 gas fee. You pay the gas fee once, but every hour you're going to pay $40. Create a function that models the cost in terms of the number of hours. So I want to put hours here. And cost right there. So now think about this. For $40, how many hours can you rent it? And it's 1. But as soon as you hit 1 hour and 1 minute, they're going to charge you again. So our chart's going to look like this. If x is more than 0, so 0 is less than x, but less than or equal to 1. Because you get that jet ski up to an hour. How much is it going to cost you? Don't write this part down yet. It's going to cost you $40 plus $15 in gas. So for that first hour, they're going to bill me 55 bucks. Now, if you use it more than an hour, so 1 is less than x, but all the way up to 2 hours, they're going to charge you $55 plus another $40. So they're going to charge you $95. Once you go over 2 hours, they're billing you again. So my next line is going to look like this. 2 is less than x, which is less than or equal to 3. They're going to add $40 to that and get $135. And my next line is going to be more than 3, all the way up to 4. They're going to bill me another $40, so $175. Like I said, my video is already 32 minutes, so I'm not going to spend time and graph it. I'm hoping from here you know how to write the function and the graph. Okay. Now, if you would come over to the last little piece, this is an easy section here, but just some symbols that you haven't seen. They're used in the stair-step function. I went ahead and did real-life examples because I felt that you would see it better. If I did it, the function would have looked like these. When you see this symbol, guys, this means round up to the next integer. What I'd like for you to do, think about a number line. Picture that number on a number line, and then figure out what number's to the right of it. So if I think about a number line, 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5. If I need more numbers, I'll put more numbers on. This says round up 3.2 to the next integer. Well, 3.2 would be a little bit more than 3. So what number's to the right? 4. So the round up of 3.2 is 4. That's what we mean by round up. Picture 7.89. If we round that up, 8. Now, the negatives get tricky. Find -2.2 on a number line. It would be about right there. Well, if you round it up to the integer to the right, it's going to be 2. Picture this. Which would you rather owe somebody, $2.20 or $2? You'd rather owe them 2, so that's called the round up. Negative 6.77, if I round that up, that's going to go to negative 6. Now, notice my next row. It looks like this. You're probably going to guess what that means. That means round down to the next integer. So when you're on the number line, you want to look to the left. So when I look at 1.51 plus 4.32, if you add those up, you're going to get the round down of 5.83. So find 5.83 on the number line and round it down to the next integer. So that would be a 5. The round down of pi is that 3.14 number that you guys used a ton in geometry. Round that down and you would get 3. The round down of negative 4? Well, wait a minute. It's already an integer, so you don't need to round it. That is your answer. These answers won't have any decimals in there. So guys, kind of a little longer video than I like, 35, 36 minutes. Hopefully you understood it. Good luck on your assignment. If you have any questions, come in and I'll get you straightened out. Good luck.